Hello and welcome to my channel. I'm your host Marcus, and today I will talk with Robert from the Part-Time Scientists about their Moon Rover. Hello Robert.
Hello Marcus.
So you're building your own kind of Moon Rover, like we see from Destiny and stuff from the Mars, is that right?
Yeah, so our very own Moon Rover, yeah, with our very own moon mission. So it's a little bit more than just a rover, because you need to get it to the moon at some point.
Okay, and is there some kind of NASA or ESA backing or anything, or is it really a private organization?
No, this is really a private enterprise, so it really is, it's not backed by government funding or so. And it's not initiated by a government project. The reason why we've said we wanted to do something like this is the Google Lunar X Price competition, which is a prize that was set out by Google, and which gives you $30 million if you send a rover to the moon by 2050. And we said, yeah, why not? Let's try to do this. Okay.
So you speculate to get the prize money if you win, but how do you get the money to actually do such a product? How much does it cost to do such a thing?
You need quite a lot of money to do something like a mission to the moon. If you were to do it the, let's say, old school governmental way, then you would have prizes starting at 350 million to 1.5 billion, which is the normal average budget for such a mission. And in our case, we try to do things a lot differently. So we're trying to using other means of development, and there's a lot to it to save money. So there's a lot of ways that you can burn money. And so we're trying to optimize everything we do. Optimizing things is especially hard when you haven't done it before in any way. So basically what our team is about is to bring some new ways of developing hardware to this field of aerospace exploration. And to get back to the number, what we're aiming for is for a development budget of about 30 million euros, which is still above the prize money.
So do you have any sponsors or something? Or are you looking for a sponsor?
Of course, first answer, of course, yes, we have some sponsors and we have some partners. We have a lot of things in between. We have investor sponsors and partners. So the difference between all of them is some people are just there, say, okay, I want to help you, so I'm giving you money, for example, to build this prototype. Some people are just technical entities, companies in the technical field would say, okay, we want to work with you on a certain technical problem and want to develop technology with you. So, for example, companies like Texas Instruments or Xilinx that do a lot of things in regards of our electronics that is inside our rovers. And then you have companies who are just interested in sponsoring you itself. So I think I forgot the last part what I wanted to say.
So I guess you have companies who want to showcase their technology through you. And the other thing is companies trying to use your project as a research platform.
Yeah, definitely. That is one point, yeah. Most of that is one thing I have to say. A lot of technology that is being used in current missions is pretty much old school and very well tested, which is a good thing, because you can pretty much say in one level that it will work in this mission. So you have an insurance, not insurance is not the right term, but a level of availability of like 0.5 or 0.7 for a mission. And we're not aiming for such a high level of redundancy in our systems. So most of the components we are using are especially just right out of the lab. So it's not hardware that has been used in space before, but it's hardware that definitely can be used in space. It's not like that we're taking like an iPod and sending it to space where everyone says, okay, it won't work. We're taking hardware into space that nobody has ever thought about using in space. And not thought about, but let's say, put it this way, it's challenging. There are some components, for example, FPGAs that we have inside our rover. I think one of my colleagues, Carsten, had a presentation at the camp right here on this topic. And these components really can do a lot of great things in space, and they really have good means of radiation hardening, but they haven't been very well used in space because everybody just uses the technology that he knows about. So, yeah.
So can we see? So what parts to make up such a rover? What's all the technology that is needed? See, we have this model here. Maybe we can talk it through.
Yeah, I can do it. The point is, there's really is a lot of building things like rovers and landers. For example, you have to think about all the big things. For example, that you can see over here, you have 3D stereoscopic cameras Then you have things like teleobjectives. So you have an optical system that can zoom in and out. So basically, if you were on the Earth, then everything sounds quite easy. But if you think about the Moon, where you have vacuum and you have a lot of heat temperature shifts from like minus 160 to plus 160 degrees, then actually building something like a telematics objective is really complicated, because the physical interaction between all parts becomes really a big problem. So there's a lot of, the devil is in the details in a lot of parts. So the basic parts that you can see over here is the energy subsystem with the solar panel. The electronics is inside the rover itself, it's beneath the solar panel. One thing that is very special about the rover is that we're using brushless drives. So they're very well used in all the RC cars right here on Earth, but they haven't been used that much in space. And they have quite a lot of advantages, because they are not, there's no traction on them, so that they're not wearing out so fast in space.
I see.
So the general principle on all the thing that we're doing is that we're trying to keep it simple as possible.
It makes sense for a project like this. So we have, what's the third camera about?
The third camera is just for Google. In this, normally we would just need 2 cameras for the stereoscopic vision, but Google requires that you send back some HD video material, and the quality that they want is not possible to do with these stereoscopic cameras in 2 fields. So we've added a third camera just for them.
So we have a Google Street View on the Moon.
Yeah, definitely. But I don't think that somebody would ask you to blur out certain things. And if so, then it would be really interesting.
I see. Perhaps an American flag or
something like
Soviet
this.
lunar lander or something.
So, but in general, it is really an exciting thing to work on such a project. You learn a lot of things. You learn a lot about people, about technology, and about organizing such an endeavor, which is something pretty cool.
So about people, do you have any people in your project with actual space experience and experience in action with the appropriate agencies?
Yeah, of course. We have several people in our team that worked at existing space agencies before, or but even worked on the Apollo program. We have our so-called, we always call them Apollo veterans. These are people that worked in the program in the 60s and did the trajectory calculations. For example, Jack Crenshaw is one of these. And he's actually the team leader of our aerospace team, so yeah.
Oh,
that's quite cool.
Very good people. So how many people do you have in the project?
In total we have about 100 team members right now. So, and yeah, this also includes all the students that we have working with us. We're working with 3 universities right now. One of them is the TU Berlin, it's the TU Hamburg-Harburg, and the TU Wien. So, and additionally to this, we have our very own team members, which is about 50 to 70 in total. So we have a lot of different sub-teams. These sub-teams are made up by all the parts that we need to do. For example, we have an engineering sub-team, and this engineering sub-team divides into a team that's building the lander and then the rover. Then you have things like an aerospace team or software development group.
So are you still looking for people with certain experiences, or people who are just interested in helping in certain fields?
Of course, we are always looking for, let's say, for skilled team members and interested. Most important, interested, but other thing is skilled team members. So if somebody is watching this and it says, okay, that could be interesting for me and I've got some time to spare and I want to help them, then we have a contact formula on our homepage and you can just get there and apply for a position at the team. Yeah. But in general, we try to keep the team as manageable as possible. So it's not our goal to have a team of like 500 people. Just to give you a number, back at the Apollo program, on the very first moon landing, there were over 35,000 people involved in just one landing.
Impressive.
So this gives you a lot of things that have a lot of, not just overhead, but a lot of things that you need to get this project done.
Of course.
That is why we're working with a lot of companies to try to get us a little bit to speed in certain fields where we don't have the right amount of team power on our side. For example, developing optics. That is something that, for example, Schneider-Kreuznach is doing, and they are developing special objectives and lenses that will work in space. In general, Schneider-Kreuznach, for example, already did build such optics for the Apollo mission.
Oh,
yeah.
Okay.
Which is something that not many people know about.
So, how do you organize a team of this size?
Organizing a team of this size is something, let's say, not really complex, but it's something that you have to do a lot of trial and error on. So it's learning by doing. So we've tried a lot of different things. At first we started out like any it's not, I don't want to call it open source style, but more like software development style approach, where you have things like a very flat structure with all the people, and then you have things like a wiki where you try to combine all the information. But at a pretty early, we decided to do a very, not too hierarchical, but a very flat hierarchical style, where we have these teams with their team leaders and their sub-teams. So you just need somebody to watch out for each team member, so it's better to have smaller teams. So having effective groups of like 5 people, 5 to 10. So if you have groups of 20 or 30 people, then it's really hard to keep track and get everyone a certain task to do. So one thing, just to give you an example of how we're working right now. Right now we're utilizing things like SharePoint from Microsoft. It's a software solution. It's pretty much like a wiki, but it's a little bit more to it. You can do like an inventory things, and yeah. So it gives you a little bit more options. And we're utilizing these things, and what we're using quite a lot is things like conferences, online conferences, voice over IP conferences with Mumble, etc., which is a software client. And yeah, things like certain, let's call it Web 2.0 tools. So it's a lot of things like Google Docs, but we're not using Google Docs. We're using a sub-product that is available as an open source product. It's called Etherpad, which is pretty much the same. It's from the same guys that developed the technology behind Google Docs. And it's pretty cool. We have something like an interactive whiteboard for every meeting. So everybody can type into it, and you can talk to each other, and everybody got the same thing on their screen, and it's quite cool. So you can participate even from the US in a meeting in Berlin, and you're in no way excluded from everything what everyone is doing.
Yeah, I think the private parties using something like that to organize.
Yeah, of course. They call it the pirate pads. Yeah.
So is your team distributed around the globe, or is most development happening at these 2 German universities?
No, it's we've got some. I hate to use this word this way, but we got some clusters in Hamburg and Berlin and a lot of places really. And we're actually in the US. We got a lot of people who work in the US. We got a lot of people in Austria also. So the team is quite distributed, but it's always, a lot of members are always centering around certain points. For example, as I said, like Berlin, Hamburg, etc. So a lot of the development, for example, with the electronics is taking place in Hamburg. A lot of the software development is taking place in Florida. And most of the aerospace calculations is in US too. For example, all the engineering, so the designing and the temperature modeling, etc., most of this is done in Austria, in Vienna.
Okay. So, because that's the next interview is taking place, do you get any help from the local hacker spaces or fab labs in the different cities?
Let's put it this way: we're doing a lot of things together. For example, like Ignite talks or meetups where we're meeting with people and just for fun start building rovers like our Azure rover. We have such a development thing. It's called the Azure rover, and it's a very good platform to develop technology that we can transfer over to our production system. Just to give you an impression, a rover of this kind has a value of like 35,000 euros. So just production costs, not the manpower encountered that you need to build it. So, and then you can't give every software developer such an expensive rover to work with. So we've developed the Azure test platform, and it's a very cheap one. It costs like up to 300 euros. So with like 300 euros, you can give every software developer the chance to build a rover that has the same capabilities exactly as this one. So they can, for example, these guys, for example, built these 3D remote control. We have a 3D navigation-based remote control, and they have to build it over, I think, 1 to 2 weeks. And it took like 8 hours to transfer it from this rover prototype to this one. And the reason for this is because we managed to utilize the exact same architecture that we're using on. So both systems are sharing the same architecture, so it's quite easy to transfer software from one place to the other.
I see. So when you have the rover, how do you get it to the moon?
Yeah, of course, you need a lander.
Okay, so you're developing a lander too?
Yep. We're also working on a lander too, but it's something that you can't do on your own. That is something where we're working a little bit more closely with companies on the aerospace field, because when it comes to propulsion parts, then it's definitely not something you want to do in your basement.
Yeah, it's explosives and stuff.
Yeah.
Well,
And because you pretty much get caught by the police just by trying to do something like this.
I see.
And yeah, the point is that the lander is actually people always ask me, Robert, what is the most complex part of this mission? And I really have to say that if I ask somebody from my team, then I get a different answer from anybody. So, for example, most companies say that the lander is the most complex system in the rover. And for example, if you ask the guys who are working on the rover, then they would pretty much say that the rover is the most complex system. So it's up to who you ask about it.
Okay.
But in generally, I have to say that the lander has some very rough tasks to do. For example, doing a soft landing, which is quite complex. So if there's just one error, then the entire mission will fail, and there's no rover going to save it.
Of course, since there's no atmosphere to wake you or to help steering.
Yeah, definitely not.
Yeah.
But in this case, I think it's good. Navigating around an atmosphere is at some points even more complex than without one.
I see.
But it's a good thing for braking, yeah, definitely.
Are you looking if any of the old school governmental agencies has already an abandoned lander design or some prototype you can build on?
That's not something we're doing, but it's something that a lot of other groups around the planet are doing. So other people are trying to build lunar landers themselves, and they're trying to do it in a way that they're using technology that has been previously built for other missions. That's not our approach. The reason is we want to change something. So as I said before, we want to cut down the costs of the overall mission. So, and to do this, one thing we're doing is we're miniaturizing parts. So we're building parts much smaller than they would be originally. So, for example, in our case, our lander is designed to fit in a payload carrier, which is basically a rocket that gets it to a certain orbit, intended for satellites. So in the satellite market, over the past years, is a very active aerospace market. So costs got cut down quite significantly. Because a lot of companies said, oh, okay, I want to launch this number of satellites, so we need to get down the costs. So this is something that we are hijacking a little bit and saying, okay, our lander design has to be suitable to fit such a mission profile. That is a little bit cheaper. So we have to build a new one.
Okay.
Yeah, but a lander that helps you to do upcoming missions a little bit cheaper once you get it.
So how far have you progressed with the lander and with the rover itself?
Yeah, our basic progress is that I think right now we are 24 months in the competition. And let's say we are quite good with the rover development. We are currently we will be presenting our R3 rover a little bit later this year. And the R3 rover is a very important one because it's the rover model that it's going to be through all the testings. So there's a lot of requirement tests where you need to see if it will work in vacuum, if it will work at a certain heat, etc. And yeah, that is something that we will start doing at the end of this year, which is very important. And just after this R3 revision, I think we will have multiple R3 rovers. It's already for sure, but and from after this R3 version, if everything works out quite as planned, then we will have an R4 version pretty soon, and the R4 model would be the flight model. So the rover would be actually finished and ready to fly. And the lander is currently in the development stage from the, as we call it, the 0 version, which is the basic concept model, to the 1 revision, where we have testing certain components. So judging by our schedule, we got like a little bit like 2 years till we have to launch. And this time is pretty much filled with all the remaining lander development and the rover development. So I can't give a number like 50%, but we're quite good at it right now. So we have reached a quite good point, but we need to do a lot of more things until we've actually finished.
So where can you do all this testing, and does it also involve destructive testing?
Yeah, that's a good point. At some points it involves destructive testing, right? And this testing took place at facilities from our partners, for example, and something, for example, at the universities, but most of the time at our partner facilities. So at some companies that have the right kinds of labs, etc. Because having the right kind of lab for this is very expensive. Just to give you an impression on this, there's a lunar test lab. It's in Bremen, and I think, if I'm remembering correctly, just building up this lunar test lab, which is a simulated lunar surface with regolith, not vacuum, but just the regolith, costed like 80 million. Oh. So you can invest a lot of money just to build the right kind of labs for your mission. So that's why we're working with a lot of entities to utilize their labs.
Of course. So you mentioned satellite systems for launch, but satellites are rather small and they're only meant to go into Earth's orbit.
Yeah.
And Moon, of course, is much farther away.
The moon is actually not so far away. It's like 400,000 kilometers. It's like 405,000 kilometers, the exact distance at the most far away point. And yeah, you're right. If you get it into, if our lander is released in low Earth orbit, then what it basically needs to do is certain acceleration maneuvers and get to trajectories, to a translunar trajectory over to the low lunar orbit, and from there on he needs to initiate his descent maneuver. So yeah, it's all about fuel calculations. So you don't have much capacity, but you still need some reserves. So yeah, it's not that easy, but what I can say is that it's not calculated on the edge. It's not like that we have 1 liter left in fuel and everything needs to fit it as quite a good...
Okay, so for something like this rover, it is possible to do a moon landing in the size of a commercial satellite instead of having something like the old Apollo capsules.
Yeah, it's definitely possible, yeah.
Extremely large rockets.
Yeah.
Okay.
And it's a good thing that it's this way. There's something you always say, you cannot change the laws of physics, which is right, but we can use the advancement of our technology.
Okay. So is there any kind of time schedule?
Yeah, our very early optimistic, let's call it optimistic launch window would be mid-2030, which is very optimistic. Let's say more realistically would be at the end of 2030. So that's the basic time schedule. And as I said before, the R3 rover is intended to be released before the end of this year.
Are you doing any kind of side projects?
We're doing a lot of technology development that is not just intended for the main mission, but it's that is be beneficial for a lot of other projects too. Yeah. One thing we're trying to work out is an enhanced communication infrastructure that you can utilize for other missions later on. Yeah.
So once you get this rover to the moon, what is it supposed to do there? Just to drive and take pictures, or also experiments?
On the lunar surface, the rover is intended to travel 500 meters, at least. And in our case, we want to travel over 5,000 meters. And it's supposed to take HD video material and send it back to Earth, of course, video and photo imagery. So one of our mission objectives is to get the rover to be able to survive a lunar night. And the lunar night is something, it's pretty cold and it's pretty long. It's like 14.5 Earth days. And gets down to minus 160 degrees, which is really a hard thing for all the things, electronic components, batteries, mechanicals, etc. So surviving the lunar night is an optional goal that we have, but we really want to try to do it.
Okay,
we would really learn a lot from it.
So any last words for our listeners?
Okay, for the listeners. Hopefully not my last words anyway. Yeah, except for just, if you're interested, just check out our Facebook page, our homepage, etc. You can find us on the internet at Hell Yeah, It's Rocket Science. Just Google it or whatever you like, and you will find us.
Just click here.
Of course.
This was a part-time scientist with their Moon Rover project. Thanks for watching. If you like this kind of content, please subscribe here and watch my blog here. Have fun!